1 and 2 and 3. Okay, end of the break. Okay, so let's get on to our kind of two-pager on developing code. And part of this, I think, is going to be useful, hopefully, when you go to your tests. The idea is get your algorithm down first, know what you're going to do, sketch it out, and then once you've sketched it out, once you know what you're going to do and you sketch it out, then you can actually start writing code that makes a difference. I'm not sure we're actually going to get to writing any code today. We have about a half an hour, which is certainly enough time to develop a solution here, but it's not really the point of what we're trying to do here. If you do want to look at the code, if you go to our code developed in class page, Lecture14 has everything you could possibly want about developing the code. We'll kind of walk our way through this. If we get to this, that would be great. If we don't get to this, then that's okay too. All right. So we want to develop a solution to a problem, and we're going to pick a fairly simple sounding problem to get started with. Basically, we don't know a lot of containers. I mean, you guys know the list container, you know tuples, and you know strings. In some sense, those are all container classes, but of them, the only one that is a classical container class as opposed to an object class is really the list, because we can actually change and maneuver around and manipulate the lists a little bit better. So we're going to focus on a solution to a problem using lists. And this problem we're going to pose is, really very simple. Let's say we have a list of data, and we want to find out something about the data. Let's say in this example, we want to find the mode, which is the most frequently occurring value. Okay, so just to review what the mode kind of is, if there's more than one of a given value, then the mode is the value with the most occurrences. It's possible that there are multiple modes. If we've got a lot of things tied at 7, then everything tied at, and 7 is the most, then everything tied at 7 becomes a mode. If everything occurs only once, then there really is no mode. The ideal thing is we get a mode, the most frequently occurring value, and the mode occurs very close to the average, which means we have, pretty much a normal distribution. So what we want to do is we want to go through and we want to kind of enumerate this, which value in this list occurs the most often. And it sounds kind of simple, but we actually have to think about what our data is. To do it right, to do it for a specific case, we actually have to know a little bit more. So the first thing we have to think about is how many values could there possibly be? Are they at least enumerable? So, for example, if I'm talking about integers, right? We have 0, 1, 2, 3. It's an infinite sequence. We could even go negative, negative 20 million or something like that. But they're each enumerable. Each one occurs. They can occur in a sequence, and we can actually count them. So that's an example of an enumerable sequence. The letters of the alphabet are another enumerable sequence. If we have anything that kind of can be corresponded one-to-one to an integer is an enumerable sequence. But if we're talking about something like floats, right, then we're no longer talking about an enumerable sequence. Or maybe we are talking about integers, but we're talking about integers from minus 20 million to 20 million, and only one out of every 100,000 values is filled in a random order. So we don't know which one of those values is actually there and which one isn't. But we know that the entire range spans this enormous range beyond where the actual value of the data is. So that's not really enumerable, not in an effective state. Floats certainly are not enumerable, because between 1.1 and 1.2, you can have 1.11 and 1.111. And 1.111111, and so on. So that's not enumerable in any extent of the meaning. So we have this kind of problem and that we have to figure out what kind of data are we talking about. If we're talking about floats, are we actually interested in 1.111111, or are we interested in the values between 1 and 1.2? You know, can we histogram these? Can we bin these together and make them make a whole bunch of values in the float space correspond to a single value, a single bin? And if we do that, can we make the data now enumerable so that we can have, 1 to 1.2, 1 to just under 1.2, 1.2 to just under 1.4, 1.4 to just under 1.6. And so divide these bins, and then the bins themselves become enumerable. So these are the types of questions we want to ask. And it's important because the solution to the mode problem can be approached at from a number of different aspects. So variation 1, a limited indexable range of values, right? So this is, again, test scores are generally 0 to 100. You have at most 100 bins. It's limited. It's enumerable. Letters of the alphabet are the same. Amino acids, those are arbitrary sequences of different chemicals. They're not really enumerable, and they're not really indexable. Variation 2, well, this is a different. This one asks us, do we want to know both the modes, and do we want to know how many times the value occurs? Is it important for us to know both, the position of the modes, what values were the modes, and the number of times they occurred, or do we just care about what the value that occurred most often is? That's kind of an important type of question as well. And variation 3, that's what I was talking about with the float data. Can we do a histogram? Is this something that instead of, it doesn't make sense to have each value be its own entry in our list of modes, but instead we want specific ranges to be important. And again, temperature, any floating point number is a good candidate for this, unless you're using very limited precision, because, where do you draw the line? When are two floating values the same? Do you have to match all the digits, all 64 bits have to be the same? Then we're starting to have something that is extraordinarily large and not necessarily very meaningful considering the accumulation of errors. I have opened to brainstorming, but I'm not sure how this is going to work. So if you type in ideas, Kristen will try to pull them out for us. Let's see. Okay. So while we're talking about that, let's just kind of talk about what we want to do. I think what we did in our example here is we assumed we had hockey scores. That was back when hockey was a big deal at RPI, back when we actually had a sports season. So let's consider the idea of going through here and extracting out these data, right? This is RPI, the other guys, RPI, the other guys, RPI, the other guys, whoever the other guys happen to be. And what we want to find out is we want to find out which score occurs most often on either side of the ledger, either for RPI, how many, these are, each one of these tuples represents the scores of a game, right? But 2 occurs here and 2 occurs here, so that means 2 occurs twice. And we want to go through and kind of parse this out. So let's think about some ideas on how to do this. Well, one thing we can think about is that let me move my microphone over here and turn on my my camera. Well, we could use okay, so there's one idea, 2 lists, one for each team's score. We could certainly do that. And then we could even concatenate those lists together at the end so that we would get, all of the scores together in a list. Right? So into one single list if we wanted combined statistics. right? So, so we have these scores. Now this is hockey, and you'll see that we threw in some big scores. I think we go as high as 30-29. But, the question we want to ask ourselves is that enumerable? And to a large extent, I would say yeah, right? And if that's enumerable, then we could either have one list or two lists. And in each list, we could have at position 0. We know that the lower bound has to be 0, right? Because we can't have anybody score negative in a hockey game. That's just not the way hockey games work, right? So we know that this would be score of 0. This could be how many times a 1 was scored. This could be how many times a 2 was scored. And we could go on until at some point, right, we have, how many times 30 was scored. And then we just have to go through, and we could also have the same thing for L2 if we wanted. So seed it all with zeros, right, up until we have the maximum score. And then we could do for all scores, right, this is the scores array. For all scores, add 1 to the appropriate bin. Right, so what does this mean? Well, when we come to the score 1, 2, we would do L1 sub 1 plus equals 1, and maybe L2 sub 2 plus equals 1, right? If we're maintaining home and away. If we're maintaining home and away separately. And if we do this, when we've gotten through all these scores, the maximum value of, so after we've done this the first time, we would now have L1 would be 0, 1, because we've incremented this 1 by 1 here. And L2 would equal something like this, 0, 0, 1, because we've incremented this 2 here. Right, so in the instance where we want to maintain the home and the away scores separately, right, we could do something like this with our 2 arrays, and that would allow us to go through and automatically, kind of magically, generate our values. Let's see, what do I have here? Just create a one-to-one function from the integers to it using a diagonal method. I'm not exactly sure what that's saying. But that's the one-to-one matching is exactly what we're doing with, in this case, the one-to-one is actually a one-to-one where a score of 1 corresponds to index 1 in the array, right? So let's look at what this might look like in actual code. And let me think about what I missed first. Okay, so I'm going to pull the scores out. So let's kind of take a look at, fair enough. Yeah, we have plenty of time. Good. Okay, so let's take a look at, let's start a new one here. I'm not going to do all the comments, but I'm going to say we now have our scores file, right? These are the scores of all the games that RPI's played, let's say last year. They're not. I don't know what the scores actually were. But we have these scores. We notice that they're relatively dense. The values go from, well, we know the values are bounded below by 0 because you can't score less than 0 points in a game. There's no penalties that can be applied to make you less than 0. And we know that this has to be limited by the number, by the maximum score on this list. So let's go through. Hunter says find the index of the maximum value. We don't even need the index. We just need to know what the maximum value is. So let's go I'm going to say most because max will get us killed. We know that it has to be 0 or positive, 0 or greater. So I'm going to start off with just by setting it to a value it can't possibly be. And now we'll just go through and we'll find the maximum score, right? Because we need the maximum score in order to be able to set up our initial array of L's with the appropriate number of zeros so that we can do this trick of just incrementing things. So let's just say I'll say scorec. In scores, I used to work, Scorec is a center on campus, and when I was a graduate student, I used to work for them. And so every time I try to type score, I end up typing scorec because I typed it so many times in papers and other communications that it seems like it kind of got burned into my fingers, muscle memory. So for score and scores, so every time through we're going to get one of these tuples. We can say something like if score sub 0, right, if the home score is greater than most, well, then we'll say most you know what? Let's do this simpler. We don't even need an if statement here. We'll just say most equals max of most score sub 0 and score sub 1. So what is this going to do? Well, what this will do is it'll take this, it's going to cycle through the scores list, right? And it's going to pull out each one of these tuples in turn, and then it's going to set most to be whatever most currently is, this value or this value, depending on which one is the highest. So if we just run this with luck, I'll run this. We should come out with most being 30, I think, right? Because 30 is the highest value in this data. So now we know that if we have lists L1 and L2 that, yeah, Max has that functionality. And no, you can't just do max scores. That's a really good question, but max scores will give you, it doesn't look into the tuples correctly. And so it'll give you the 3029, which is the 30 if .30 comes first, because it does a comparison in order. So if we do it, so this gives us 3029, but if it were swapped, or let's say 130, right? And now we do max scores. Right, max scores would give us something completely different because it only looks at the first one, at the first value first. That's how it does comparisons with tuples. Right, so now it gives us this as the maximum tuple. So you have to be a little careful on it. And let's change this back. Not that it matters, but there we go. And And max score 0 would return 3. That's exactly true. Okay, so this gives us the most and most. So now we need our two arrays, right? So now the next thing we have to figure out is, well, we've decided this is an enumerable and indexable case, right? So we know all the values that could possibly be there. The only values that could be there are from 0 to 30. So we can come in and we can say, I'm going to call them home and away. Home equals most plus 1, right? Because if we have to hold the values from 0 up to 30, that's 31 values. So that would be most plus 1 times the list whose member is 0. And we'll do the same for away. Okay, and when we run that, hopefully home is a list of 30 zeros, 31 zeros, and away is also a list of 31 zeros. Why didn't we do this instead of replicating that line? Okay, aliasing, exactly. If we do this, home and away are the same array. So every time we incremented one, we would increment the other. All right, so now we've got our arrays set up. So now we've got the L1 and the L2 that we had on the other board, although this time we're calling them home and away. And now we can actually just walk through in another for loop. Right, so we're going to walk through our scores array again, but this time instead of looking for the maximum score, every time in we're going to say away. Okay, so I'll start off with home. We're going to increment one of the values of home to have occurred one more time. So we know scores is this tuple. We know that this is the home team's score. So we can say home, and we want to take the home team's score sub 0, right? So for each score sub 0 is the home team's score. So the first time through, this will evaluate to 3. So the home team scored 3. And so 3 has occurred one more time than it had before. So we can just increment it by 1. Okay, so now we have our home array. Every time we find a 3, home sub 3 is going to be incremented by 1. Every time we find a 0, home sub 0 is going to be incremented by 1, etc. And now we can do the same thing for the away score, except for the away score, we don't want to increment the home array, we want to increment the away array, and its score is going to be stored in score sub 1, right? Because the away team is going to be stored here. Okay, and now when we run this, what we should get is in our home and away, right? We should be able to see there was one score of 0 in home, there was one score of 1, there were 3 scores of 2, right? There's our 0, there's our 2s. There was one score of 30, one score of 29. So now we have the occurrence values of each of the possible scores for home, and we should have a similar one for away. All right, away has 3 29s, by the way. 29, 29, 29. There you go, right at the end. And with this, now we can figure out what the mode is. We can figure out both the value that's the mode and so the mode would be, right, the mode would be the home H mode would be, well, home occurrence would be the max of the home list, and away occurrence, how many, the maximum occurrence number would be the max of the away array, right? And then we could go through our list, our home and away. Yeah. Now we can go through our home and away arrays, and we can find out what the actual modes are by looking at where those maximums occur for val in home, if val is equal to h occur, we can just print out print sorry about that, I did this wrong. We'll have to use an index here. Right, so we'll print out counter, which will be the point, the value, the score that occurs the most often, and the number of times it occurs. And we could always do the same thing here for the away array. So we'll do this as well. And we can get away with this little shortcut because we know that the home and the away the home and the away arrays are the same length. So I think this will work. Let's see what this gives us. Okay, so this says that the home scored, I should probably put home and away in here. So it says that the home scored, most often scored 3 goals, two goals, and they did that 3 times. Sorry, most often scored 2 goals, and they did that 3 times. And the away team most often scored 29 goals, and they did that 3 times. So I should have chosen that in a different order. Okay, so that's one way of doing this. We've got about 5 minutes. I don't have time to do a really good job on the next set. But the other thing we can do is actually even a little simpler. So maybe we do have enough time. What if this isn't enumerable and indexable? What if instead we have a bunch of values, they're discrete, right? So they're not like floats where we have to worry about ranges, but they are, for example, maybe this spans 20 million. So we don't want to actually define an array of 20 million values. We can do something kind of similar. We can do something like, and I'm just going to do a single one for this. We'll say L equals an empty array. Instead of trying to find out how many occurrences there are, let's just take and we'll do what was suggested before. We'll just do an append into here. We can say for score in scores, we can do an L dot append score sub 0. And we can do an L dot append, and this is putting both the home and away into the same bin, into the same, we're not going to separate home and away, right? But at the end, what we'll have is we'll have a list with all of our score values in it, and we can run this. We can look at L, right? So that's all the possible values that have been scored. And now if we come through and we just sort this, we can do L dot sort. Now we have everything in the same order. Right? And we can look at L again, and now all of the same values are grouped together. So if we do this, and here's where I'm going to kind of cut, we're kind of running out of time, I'm going to cut back to my cheat. When we kind of do this, what we've done is we now have all of our values, in this list, and we can go through and we can say our first value is right. This is where we're sitting. We're right down here. We can keep an index of what's the maximum number of scores we've counted, where we're sitting, the element value from the previous grouping, and the count. And what we can go through is we can go through and we can as we go through our list, as we walk through this as we walk through this array, right, this can continue on. What we can say is we're counting the number of zeros. So we count 0, 0, 0. We count 3 zeros. When we go to here, now this is different from this value, right? So we have the previous is, right, prev equals 0. We count 0, or 1, 2, 3. We get to a point where we've reached a different value. This is no longer equal to prev, and we would have like a max equals -1. We say if count is greater than max, greater than or equal to max, well, if it's greater than max, then we want to process a new maximum mode. If count equals max, then we want to add an additional mode at count, right? So that means that our current maximum is 3, for example, and now we found another score that has 3. Otherwise, we just want to continue on. Reset count to 0 and start over again with 1. So now when we hit here, prev would be 1, count would be 0, and now we would say 1, 2, 3 again. Now they're different. So we're just going along counting how many occurrences in a row, and because we have this sorted list, we can do that really efficiently. Okay, and that's kind of what's going on here. We walk through the list, right? Walk through every value in the list. If we find a break, where we find we've gone from 0 to 1, we check our counts. If this is a new maximum, we create a list with just this new maximum as the only mode, and with the current number of occurrences for the mode. Otherwise, if we're changing and we've reached, right, when we change, we've actually equal to the previous mode, well, then this is just an additional mode and nothing else has to change. Otherwise, regardless, once we've made that decision, we now reset it and start counting again the next string, 1, 2, and 3. Okay, and so this is for an enumerable, something where we don't have to do binning, but where we may not be able to index it. Maybe the index range is too large. It isn't really necessary for 30 scores, but it's certainly doable. All right. I am going to, I think that's about the end of this. Yeah, we'll wrap this up. I'll hang out. I can only hang out for about 10 or 15 minutes today. I've got another meeting in about, well, I've got another meeting that's supposed to start at 4, but if I'm 5 minutes late, nobody will be too upset. Anything I can help you guys with? Yep. The parsing formats, you should understand what a parsing format is. We've done a bunch of the ad hoc stuff. All the splits you've been doing to get the paragraphs. Essentially, that's a data parsing problem, right? You did a split. Some of you did splits at the periods to figure out how many sentences. You did splits at the spaces to find out, or at the white space to find out how many words you have. So the ad hoc formats are important, but you've already been doing those, and you've been doing those with string operations. So you should be able to continue to do those. We're not going to ask you specific questions about HTML, but if I were to tell you to find out where this HTML tag, given an HTML tag, find it or find out where it ends or something like that in a string, you should be able to do that because you have those operations. You don't have to know the formats themselves, but you should be able to apply the operations you already know to a parsing problem that we were to pose to you. None of those are anything special compared to what you've already been doing. There's nothing really new there other than we were just showing you how it was applied in real life. Make sense? So don't bother memorizing the formats, but think a little bit about what they actually mean, and particularly with respect to what we were asking you to do in the paragraph analysis types of things, or in parsing out the address lines in the Yelp data, for example. Okay.